Good afternoon, grade 10s. Alright, paper 2 is on the way. Let's have a look at analytical questions or mechanical in general. Alright, first of all, you'll be greeted with a nut here on the page. It says it has 2 faces and 3 faces. So you know the difference. Then the diameter of the nut and the bolt, you use m times 1.5 to get that diameter. The chamfering part that you see there on the bolt, and that's also for the nut, is 30 degrees. For the nut alone, you see the height is m times 0.8. For the bolt, that's going to be different. So make sure you know which one you are drawing. Then the 60-degree angles that you see here is for to be able to draw the circles, or the half circles there. Now for the bolt, we are looking at 3 faces, and then on the right there's 2 faces. The M quality is the diameter of the bolt, right, of the M, of the shaft. Then here you can see the difference. M times 0.7 is for the bolt height, which we've already discussed quite in length throughout the year. Alright, having a look at the thread, all the way at the bottom you can see it's chamfered, or it stops on a 45-degree angle. The thread itself is m times 0.1. Alright, so just have a look at that. That's going to be quite important. On the right hand side you can see the formula for the thread length from the bottom all the way to where the thread ends is m times 2. That's also very important. All these formulas you need to know from the top of your head. Chamfering is exactly the same like we said. So there you have it. Best of luck. Alright, here we have your isometric. The front view and starting point A has been given. Right, make A the lowest point of your drawing. No hidden detail is required. That's the most important. So the 2 views that they gave you is the top view and the front view. Alright, so first of all, A is going to be the lowest point when you start, right? Isometric meaning 30, so 30-degree angle that we use here. Right, so having a look and see where your front view is going to be. Technically, if you look at your drawing, that's the front view, and on the left is the left view, right? Because it's third angle orthographic projection. Starting the drawing, having a look at the height, which is 10. Right, here on out, you can just follow the drawing and see all the way up until I'm starting with the circle and the hexagon. Right, so you can see the length. You'll see me indicating on the drawing a few numbers. You can pause and reflect back on them, and then I'll give some additional information once we get to the hole that you see there on the top view. Alright, starting with the square hole that you're going to see in the drawing. First of all, you can see there it gives you indication a measurement of 20. That's across flats, right? So that's from one flat side to the other one. So in order to start this drawing, you use a radius 10 circle, okay? Because the diameter is, or this cross flat is 20. From here on out, you can see, just measuring it, you can see it's a 45-degree angle, and you can start by drawing tangent lines, right? That's a touching line on the 45-degree angle on that circle. This is going to act as your auxiliary view, which you have to use to measure from to draw the square. All right, so there we have the auxiliary view. Now we can determine the center points on the drawing, and then we should be able to plot this easy and get the measurements. Alright, using the middle point of the auxiliary view, you can see I'm just going to line it up with the middle point there, and the distance from the middle to the side is what I have to measure. So if you look at it, you can see it's going to be 14 millimeters, right? So if you place that down from the middle, it should be 14 as well. Alright, just double checking myself. So on all four of these sides, you are going to measure 14. And that should give you the sides that you can just go ahead and connect. Now lastly, what you can also do is, this is supposed to be a square hole that goes through this figure, which means you're supposed to see the inside of the shape. So having a look at the width, you can see that distance is how deep the hole is going to be. So we started using 10, and there you go. Alright, I'll give some additional information once we get to the auxiliary view of the hexagon. The rest should be pretty straightforward. Alright, now we're in the position where we got to the auxiliary view. So the first thing that we need to do is we need to actually redraw a hexagon, right? We only need half of the hexagon because we need to determine the xy. So now we get to the hexagon. The base is 24, which means there's the line, my starting point for the base, 24 millimeters that you measure on there. Then the hexagon is drawn using a 60-degree angle. That's the one I'm using there. And then the side length is also 24 because all the sides are equal. And by having this, you can draw those lines together and you should get the XY axis that you need. Right, so X and Y. So why we need to do this, because we need to measure the X and we need to measure the Y in order to place it on the isometric drawing itself. Right, so here we can see X should be 12 and Y in this case is 21. Alright, so it's easy to get X. You can get X without having to use the auxiliary, but Y, like you can see up there, is the one we need. So we already have the center point of the hexagon, which means there's 21, so it's Y. And now on a 30-degree angle going in, we have to measure X. Alright, so I'm just connecting the top there, so you can see that's also supposed to be Y. And here we go for X, which is 12. And from the top, you can also measure X. And now that should leave you with a base. Alright, you'll see now how everything comes together. Alright, there you go. Okay, just note I'm drawing in the whole thing. Even though it is subject to change, some of this is going to change in a minute. I just want you to see the image before we elevate this auxiliary view up a bit. So I'm going to erase some of this, but just take note, as this is what we are kind of looking at. Alright, so this would be, if this hexagon was not elevated, then this is what you would have had. So from here on out, I'm just going to draw a line straight up. You'll see I'm going to get the hexagon on the left hand side as well, just by projecting the X points in. And then I'm getting the height, which is going to be 15. It's going to be elevated by 15. Here you can see I'm indicating to you the height there is 15. So that's what I'm about to do. I'm going to bring all the points over. I'm going to elevate all those points by 15. And then I'm just going to connect them. Alright, and the last line here. There you have it. That would be your hexagon. You can see at the back there, no hidden detail is required, but there you go.